The year is 1971, and on the pages of a popular Soviet science magazine, an engineer named Gennady Nesterenko unveils a vision so audacious it seems torn from the realm of science fiction. A nuclear-powered airship, 300 meters long, capable of carrying nearly 2,000 passengers across continents without refueling, propelled by twin 20-meter propellers and sustained by a 200-megawatt nuclear reactor. This was not a fantasy dreamed up in isolation. It was the culmination of decades of Soviet ambition, technological optimism, and a peculiar faith in the resurrection of a technology that the world had already abandoned. To understand how the Soviet Union arrived at this extraordinary proposal, we must first travel back to the golden age of lighter-than-air flight, when dirigibles ruled the skies and the future seemed boundless. The story of airships begins not in the Soviet Union, but in Imperial Germany, where Count Ferdinand von Zeppelin pioneered the rigid airship design that would bear his name. By the 1910s and 1920s, Zeppelins had become symbols of modernity and technological prowess. They crossed oceans, carried passengers in luxury, and demonstrated that humanity could conquer distance in ways previously unimaginable. Over their entire operational history, civilian airships completed approximately 2,500 flights and transported more than 28,500 passengers. These were not experimental toys. They were serious instruments of transportation, and the Soviet Union watched with intense interest. The Soviets entered the airship race with characteristic determination. By the late 1920s, the USSR had established its own dirigible construction programs, recognizing that the vast, often roadless expanses of Soviet territory were ideally suited to airship travel. The logic was compelling. Traditional infrastructure, roads and railways, required enormous investments in materials and labor, especially across Siberia and the Arctic regions, where permafrost and extreme weather made construction nightmarish. Airships, by contrast, could float above these obstacles, connecting remote settlements and industrial sites with relative ease. The Soviet leadership saw in dirigibles not merely a transportation method but a tool of state consolidation, a way to bind together the sprawling territories of the world's largest country. In 1929, the German airship Graf Zeppelin achieved a feat that captured global imagination. It circumnavigated the globe in just 20 days, making only 3 intermediate landings. This was speed and endurance that no other form of transport could match at the time. The Soviets responded with their own record-breaking achievement. The SSSR Vyovy-6 Osoaviakim, a Soviet-built airship, remained aloft for 130 consecutive hours without landing, setting a world endurance record. This was more than a propaganda victory. It demonstrated that Soviet engineering could compete with and even surpass Western achievements. The V-6 became a symbol of Soviet technological capability, a floating testament to the possibilities of socialist planning and industrial might. But the airship era was not destined to last. Even as records were being set, the inherent vulnerabilities of lighter-than-air craft were becoming tragically apparent. The 1930s witnessed a series of catastrophic accidents that shook public confidence and forced governments to reconsider the viability of dirigible transport. The most famous of these was the Hindenburg disaster of 1937, when the massive German airship burst into flames while attempting to land in New Jersey, killing 36 people in a spectacle captured on film and broadcast worldwide. The image of the burning Hindenburg became synonymous with the failure of airship technology, a cautionary tale of hubris and flawed design. For the Soviet Union, the final blow came not from foreign disaster, but from domestic tragedy. In 1937, The same year as the Hindenburg catastrophe, the SSSR V-6 Osoaviakhim, the very airship that had set the endurance record, met its end in the harsh Arctic. Flying through a polar night in brutal weather conditions, the crew lost their bearings. The airship crashed into a mountainside, and the entire crew perished. This was not merely a technical failure. It was a political embarrassment, a demonstration that Soviet technology, for all its achievements, remained vulnerable to the same forces that had destroyed Western airships. The Soviet leadership, always sensitive to signs of weakness, responded decisively. Airship construction programs were shut down. Resources were redirected to fixed-wing aircraft, which were proving far more reliable and versatile. By the end of the 1930s, the Soviet airship industry had effectively ceased to exist. For 3 decades, dirigibles remained a dead technology, relics of a bygone era. The Second World War and the subsequent Cold War focused Soviet attention on bombers, fighters, missiles, and eventually spacecraft. The skies belonged to airplanes and rockets, not to slow-moving gas bags. Yet the dream of airship travel never entirely died. In certain circles, engineers and visionaries continued to believe that lighter-than-aircraft had been abandoned prematurely, that the fundamental advantages of dirigibles, their cargo capacity, their fuel efficiency, their ability to hover and land without runways, had been overshadowed by a few dramatic accidents. What these advocates needed was a solution to the airship's greatest weakness: limited range and endurance due to fuel constraints. And by the 1960s, the Soviet Union possessed a technology that seemed to offer exactly that solution: nuclear power. The Soviet nuclear program had achieved remarkable success. The USSR had developed not only nuclear weapons, but also nuclear reactors for civilian and military applications. Soviet engineers had built nuclear-powered submarines that could remain submerged for months, and nuclear icebreakers that could smash through Arctic ice year-round without refueling. The logic of applying nuclear power to airships seemed, to some, irresistible. A conventional airship's range was limited by the weight of fuel it could carry. As fuel was consumed, the airship became lighter, requiring constant adjustment of ballast to maintain altitude. But a nuclear reactor, once installed, provided power for years without refueling. Its weight remained constant. The airship would not need to carry tons of aviation fuel. It could, in theory, fly indefinitely, limited only by the endurance of its crew and the maintenance needs of its mechanical systems. This was the context in which Gennady Nestorenko, a candidate of technical sciences, presented his proposal in the pages of Technika Molodeži, Technology for the Youth, a popular science magazine that served as a showcase for Soviet technological ambition. The magazine, widely read by young engineers and students, had a history of publishing speculative but technically grounded proposals for future technologies. Nestorenko's article, appearing in 1971, was one of the most thoroughly developed airship concepts ever presented in the Soviet press. It was not a vague fantasy, but a detailed engineering proposal, complete with specifications, performance estimates, and arguments for economic viability. Nestorenko envisioned an airship 300 meters in length, comparable in size to a nuclear-powered aircraft carrier or the largest ocean liners of the era. This was significantly larger than the Hindenburg, which had been 245 meters long, but not impossibly so. The airship would be lifted by helium, the inert gas that had replaced flammable hydrogen after the Hindenburg disaster. Helium was expensive and, for the Soviets, difficult to obtain in large quantities, but it was safe. The nuclear reactor would not contribute to lift. It would simply provide propulsion and electrical power. The reactor proposed was a 200-megawatt unit, similar in output to the reactors being installed on Soviet Arktika-class icebreakers. These were proven designs, compact and reliable by the standards of the time. The airship would be driven by enormous propellers, each 20 meters in diameter, powered by electric motors fed by the reactor. Nestorenko estimated that the craft could achieve speeds of 200 to 300 kilometers per hour, significantly faster than the 100 to 130 kilometers per hour typical of earlier airships. This speed, while still slower than jet aircraft, was competitive with propeller-driven planes and far faster than ocean liners. More importantly, the nuclear airship would not need to land to refuel. It could fly continuously for months, limited only by the need to resupply food and water for passengers and crew. The cargo and passenger capacity was staggering. Nestorenko calculated that the airship could carry 180 tons of cargo, or, if configured for passenger service, 600 travelers in luxury accommodations comparable to first-class ocean liner cabins. If comfort was sacrificed and passengers were packed in more densely, the airship could accommodate up to 1,800 people. This was not a small commuter vehicle. It was a flying city, a mobile platform capable of transporting entire communities or massive quantities of freight across continents without the need for airports, runways, or extensive ground infrastructure. The appeal of such a craft for the Soviet Union was obvious. The USSR remained a country of vast distances and underdeveloped transportation networks. Despite decades of investment, large regions of Siberia, the Far East, and the Arctic remained difficult to access. Roads were few and often impassable in winter. Railways existed, but were expensive to build and maintain across permafrost. Air travel required runways and fuel depots, which were costly to establish in remote areas. A nuclear airship, by contrast, could land almost anywhere using its ability to hover and descend vertically. It could service remote mining operations, scientific stations, and indigenous communities without the need for fixed infrastructure. It could transport heavy machinery, construction materials, and prefabricated buildings to sites where conventional transport was prohibitively expensive. Nestorenko and his supporters also emphasized the comfort and prestige of airship travel. They pointed out that many passengers still preferred ocean liners to airplanes, despite the longer travel times, because ships offered spacious cabins, dining rooms, lounges, and the ability to move around freely. Air travel, even in first class, was cramped and uncomfortable. A nuclear airship, they argued, could combine the speed of air travel with the comfort of sea travel. Passengers could enjoy large cabins, observation decks, restaurants, and recreational facilities while crossing continents at several times the speed of a ship. For international travel, especially to remote or undeveloped regions, the nuclear airship could offer an experience no airplane could match. There were also military and strategic considerations, though these were not emphasized in the public presentation. A nuclear airship could serve as a long-endurance reconnaissance platform, hovering over remote borders or oceans for weeks at a time. It could function as a flying command post, coordinating operations across vast theaters. It could transport troops and equipment to regions where airlift capacity was limited. The Soviet military had long been interested in unconventional solutions to logistical challenges, and a nuclear airship offered capabilities that no other platform could provide. Yet, for all the apparent logic and technical feasibility of Nestorenko's proposal, the nuclear airship was never built. The project remained confined to the pages of Technika Molodezhi and the imaginations of its readers. No prototype was constructed. No funding was allocated. The Soviet leadership, despite its well-documented enthusiasm for grand technological projects, showed no interest in reviving dirigible construction. To understand why, we must consider the broader context of Soviet technological priorities in the 1970s and the practical obstacles that made the nuclear airship far less attractive than it appeared on paper. First, there was the question of safety. The Soviet Union had experienced numerous nuclear accidents, though many were kept secret from the public. The idea of flying a 200-megawatt nuclear reactor through the skies, potentially overpopulated areas, raised obvious risks. A crash, even a minor one, could result in the dispersal of radioactive material over a wide area. The biological shielding required to protect passengers and crew from radiation would add enormous weight to the airship, reducing its payload capacity and negating some of the advantages of nuclear power. The reactor would need to be designed to survive a crash without breaching, a challenging engineering problem that had not been fully solved even for ground-based reactors. Second, there was the issue of helium supply. The Soviet Union did not possess large domestic sources of helium. Most of the world's helium came from natural gas fields in the United States, and Cold War politics made it difficult for the USSR to import helium in the quantities needed for a large airship program. Hydrogen, the alternative lifting gas, was far cheaper and more readily available, but its flammability made it unacceptable for a craft carrying a nuclear reactor and hundreds of passengers. Without a reliable source of helium, the nuclear airship concept faced a fundamental material constraint. Third, and perhaps most importantly, the Soviet Union had already invested heavily in alternative transportation technologies that were proving highly effective. The Soviet airline industry, Aeroflot, was expanding rapidly in the 1970s, with new jet aircraft connecting remote regions to major cities. Helicopters, particularly the heavy-lift models being developed for military and civilian use, provided vertical takeoff and landing capability without the vulnerabilities of airships. Icebreakers and specialized Arctic ships were opening sea routes through the Northern Sea Route, providing year-round access to Siberian ports. The economic case for developing an entirely new class of vehicle, with all the attendant costs of research, testing, and infrastructure, was weak. There was also a cultural and political dimension to the decision. By the 1970s, airships were associated with the past, with the technological optimism of the interwar period that had been shattered by war and disaster. The Soviet Union prided itself on being a forward-looking society, a pioneer of space exploration and advanced technology. Dirigibles, even nuclear-powered ones, seemed like a step backward, a revival of a failed technology rather than a leap into the future. The Soviet space program, with its achievements in satellite launches, manned spaceflight, and planetary exploration, captured the public imagination and the attention of leadership in ways that a nuclear airship never could. Nestorenko's proposal also appeared at a time when the Soviet economy was beginning to show signs of strain. The rapid growth of the Stalin and Khrushchev eras was slowing. Resources were increasingly directed toward the military and the space race, leaving less available for experimental civilian projects. The nuclear airship, for all its potential benefits, was not a priority. It solved problems that could be addressed, albeit less elegantly, with existing technologies. It offered capabilities that, while impressive, were not essential to Soviet strategic or economic goals. The story of the Soviet nuclear airship is thus a story of roads not taken, of technological possibilities that remained unrealized. It reflects a moment in Soviet history when the confidence of earlier decades was giving way to a more cautious, conservative approach to innovation. The grand projects of the Stalin era, the massive hydroelectric dams, the Virgin Lands campaign, the early space program, had been driven by a belief that Soviet science and engineering could overcome any obstacle. By the 1970s, that belief was tempered by experience. The Soviet leadership had learned that not every ambitious project succeeded, that resources were finite, and that technological prowess alone did not guarantee economic or political success. Yet the nuclear airship concept also reveals something important about the Soviet approach to technology. The proposal was not dismissed as absurd or impossible. It was seriously considered, published in a respected magazine, and discussed by engineers and scientists. The Soviet system, for all its flaws, encouraged bold thinking and speculative design. It created space for engineers like Nestorenko to imagine alternatives to conventional solutions, even if those alternatives were never implemented. This culture of technological imagination produced both spectacular successes, like the Sputnik satellite and the first human spaceflight, and spectacular failures, like the failed moon program and numerous industrial accidents. The nuclear airship falls somewhere in between, a project that was neither successful nor failed, but simply never attempted. In the decades since Nestorenko's proposal, the world has seen periodic revivals of interest in airship technology. Modern designs, using advanced materials and computer control systems, have promised to overcome the limitations that doomed earlier dirigibles. Yet none have achieved widespread commercial success. The fundamental problems remain. Airships are slow compared to airplanes, vulnerable to weather, and require specialized handling and infrastructure. The economic niche they might fill, long-distance transport of heavy cargo to remote areas, has been largely addressed by improvements in helicopter technology, cargo aircraft, and ground transportation. The nuclear airship, in particular, remains a technological dead end. The safety concerns that prevented its development in the 1970s have only intensified in an era of heightened environmental awareness and stricter nuclear regulation. No country today would seriously consider flying a nuclear reactor through civilian airspace, regardless of the potential benefits. The risks are simply too great, and the alternatives too well developed. Yet, the story of the Soviet nuclear airship endures as a fascinating glimpse into a moment when the future seemed radically open, when engineers could seriously propose flying nuclear reactors across continents and expect to be taken seriously. It reminds us that technological progress is not inevitable or linear, that promising ideas can be abandoned, and that the path of innovation is shaped as much by politics, economics, and culture as by technical feasibility. The nuclear airship was a product of its time, a reflection of Soviet technological optimism and the unique challenges of governing the world's largest country. It was never built, but it was imagined. And in that imagination, we can see both the ambitions and the limitations of the Soviet project. A system that could dream of nuclear-powered sky cities, but could not find the resources or the will to make them real.